This assessment asks us to predict the product of the base-catalyzed aldol. So we're going to react this aldehyde in the presence of sodium hydroxide and water. I've gone ahead and redrawn the aldehyde up here. This reaction will start with the deprotonation of the alpha hydrogen by hydroxide. And so we can show that step happening here to make the enolate. Now, this reaction we'll use the equilibrium arrows and remind ourselves that because hydroxide is not that strong of a base, the majority, this equilibrium is going to be favored to the left side. So we will have made some of the enolate, but the majority of the aldehyde will be in the aldehyde form. What does that mean? Well, that means that the next step is going to be this enolate reacting with that aldehyde that it started as. So again, it's a different molecule, right? We've made one of these, but we still have lots of this. And so this enolate will react with this aldehyde. We can show that by the electrons coming down to reform the pi bond, pushing the pi electrons out to attack the carbon of the carbonyl. Now at this point, it would be a good idea to number carbons. I'll do that after I draw the product, but that will be helpful to make sure we have the product drawn correctly. This is the aldehyde that was the enolate. So let's put in those numbers, 1, 2, and we'll just put a 3 for the phenyl group. 1, 2, and 3 for the phenyl. Notice that carbon 2 attacked the aldehyde carbon. So we can draw a bond up here, and we'll put the numbers as different. We'll call this 4, 5, and 6 for this one, even though it's starting with the same molecule. That means that this is carbon 4, is attached to carbon 5, which is attached to the phenyl group that we have labeled as 6. All right. What else is at carbon 4? We now have the oxygen. We originally had a carbon-oxygen double bond. Now we have a carbon-oxygen single bond. Those pi electrons are now on the oxygen, and so that oxygen has a negative charge. This is the product of the first step of this reaction. Now we have water around. We can protonate that alkoxide to complete this reaction and regenerate hydroxide. We said that this was a base-catalyzed aldol. We're reforming the hydroxide that we used in the first step. That's what is doing the catalysis. That allows us to draw the product of the reaction, though, as follows. We could number to make sure that the product is still correct, but the numbers should still work out. 1, 2, and 3, 4, 5, and 6. This is the product of the reaction on screen.